Hello everyone, we'll continue with our lesson 3, light. You all have seen rainbow. When sunlight hits raindrop in the sky, you can see a rainbow. But have you ever thought that why and from where do we see the colors and from where do they come? The colors are already in the sunlight that produces the rainbow. Our eyes see light waves with different wavelengths as a different color. Visible light waves with longer wavelengths look red. You can see here they have longer wavelengths. Now visible light waves with shorter wavelengths look the violet. This is the violet color with the purple color. You see that their wavelengths are quite shorter. Now all the color between red and violet, they have wavelengths that are between them too. So they are between them, some of them longer with indigo, blue, green, yellow a little bigger, orange a little bigger. When light such as sunlight is actually just a collection of many different wavelengths mixed together. So white light is made up of these different colors. Different wavelengths of light will reflect and it reacts or refracts at different angles. This explains why white light that is reflected by raindrops in the sky is spread out into a rainbow. So it is refracted. Remember we talked about lenses doing that, refracting the light. So the same thing is done here. The light, white light that is refracted by the raindrops in the sky, it is spread out into a rainbow and you're able to see that rainbow. So a prism is a cut piece of clear glass or plastic in the form of triangle or other geometric shape. And what does this prism do? That the band of color, for example in a rainbow, or like we said in a rainbow, the raindrops in the sky do that. They refract the light and it turns out to the rainbow. In a prism the same thing happens. The white light is refracted and then it comes out in the shape of these 7 colors. We call them a spectrum. Whether it's a rainbow or whether the white light passing through this prism, all right, this band of the color is known as spectrum. Again, the rainbow is also a spectrum because the raindrops do that. They refract the light, white light, and expand it into 7 different bands of color. Here the prism does the same thing. White light is refracted and spread into 7 colors. This is known as spectrum. There were objects that we said light passes through and does not passes through them, like the opaque objects, transparent objects, and the translucent object. When an object scatters, it absorbs or transmits light depending on the wavelength of the light. So when light hits an opaque object such as this one, you can see here, it is scattered or absorbed. So you see that all other colors, white light coming in, we said white light is made up of these 7 colors. White light is made up of these 7 colors. All these colors are absorbed only apart from the red light, which is scattered, which is reflected back, and that's why you see that color as red. So all the other colors are absorbed by this opaque object and only one color here is reflected back. It scatters out. On the other hand, the translucent object, some colors are absorbed and others they pass through it. Translucent objects appear the color of the light that passes through them, so they absorb all other colors of light apart from one color, same as the opaque, some of them passes through it. While the transparent object, the picture, for example, because all the color passes through it and you can see clearly things in there. So the picture on a color television is made up of red, green and blue dots of light. Have you ever thought why these colors are used? Only 3 colors. So any color of light can be created by mixing the red, green and blue light in the right amounts. For this reason, red, green and blue color are known as the primary colors of light. If mixed equally, red, green and blue light produces a white light. If we equally mix them, you can see it creates a white light. On the other hand, we have another collection of magenta, cyan and yellow that is often used to create colors by scattering. Remember scattering, when they are bounced off at different angles. For example, you may want part of a picture to look like blue and mix when light strikes it, or you could mix equal amount of magenta and cyan paint. Magenta scatters only red and blue. Okay, you can see it scatters red and blue. Then you have the cyan scatters only blue and green. So when the two are mixed, magenta absorbs cyan's green and they can absorb magenta's red. So together they only scatter blue color. So this is also a collection of colors which scatter, which bounce back the colors at different angles. The way in which electric and magnetic forces interact is called the electromagnetic spectrum. We know that light is made up of electric and magnetic waves that can move through the space. So light is just a form of electromagnetic radiation. Electromagnetic spectrum tells us about the different electromagnetic radiation beside visible light. Apart from visible light, there are other electromagnetic radiations also, which we cannot see. They differ in wavelengths. They have different wavelengths and energy. Together they make up the electromagnetic spectrum. So this is the electromagnetic spectrum. Now, what single source can produce all forms of electromagnetic radiation? Stop the video and think it. If you said sun, you're right. Most of the radiation from the sun is infrared, visible and ultraviolet light. So you have the infrared, visible, ultraviolet radiations. These radiations on the electromagnetic spectrum, their source is the sun. Solar flares, however, give off all forms of electromagnetic radiation when they erupt. So we have here the radio waves, microwaves with longer wavelengths. You can see you have infrared light also with some longer wavelength. Visible light, here we have visible light. Then you have the ultraviolet rays, which are the harmful rays of the sun, and that is that in the atmosphere we have layers which filter this ultraviolet rays. Then you come to the X-rays and the gamma rays. You see that they have very shorter wavelengths and they're very strong, and we can't see them. They have, apart from ultra-visible light, we can't see actually any radiation. But if you compare to the wavelengths, the radio waves, microwaves, infrared light, visible light have somehow longer wavelengths. But if you come to the X-rays and gamma rays, you see that wavelengths are quite shorter. It means they are more stronger. Thank you for seeing and watching. We finished the lesson today of light. Please solve the workbook related pages and send them on Pioneer, and please feel free to ask any question.